Section 6.7 is solving systems of linear equations. When you have two or more linear equations that you consider at the same time, the equations are called a system of linear equations. So when you look for a solution to a system of equations, it's going to be an ordered pair that satisfies every single equation that is listed in the system. A system of linear equations can have exactly one solution. It can also have no solutions or infinite solutions. So first thing I want you to do is to just practice whether you can tell if a point is a solution to a system or not. The easiest way to verify this is to just substitute the point in. So let's say that I gave you the system, and the first equation was x plus 2y equals 12. And I want to know if the point 0,6 is a solution of this equation. So you'll substitute 0 in for the x, you'll substitute 6 in for the y, and you'll look to see if this makes a true or false statement. So if you notice, 0,6 does satisfy the first equation. So then we need to check it in the second equation to see if it also satisfies that equation. Our second equation is 2x minus y equals negative 1. And again, we'll substitute the 0 in for the x and the 6 in for the y. And we'll use our order of operations to simplify. And notice that it did not work for the second one. Well, that means the point 0,6 is not a solution to the system. In order to be a solution to the system, it must work for both equations. Let's try our next point. Our next point is 2, 5. So again, we're going to try it in our first equation. X plus 2y equals 12. We'll put the 2 in for the x and the 5 in for the y. And it does work for the first equation. We get a true statement. And then we'll try it in the second equation. I'm going to make a little room here. Oops. Let's get us some more blank space. Let's try it in our second equation. Our second equation is 2x minus y equals negative 1. And again, we'll substitute the 2 in for the x and the 5 in for the y to see if we get a true statement. And this time it worked for both equations, which means the point 2, 5 is a solution to the system. Most of the time they don't give you the points, and so you'll have to figure out your own solution. One method that you can do this is the graphing method. When you do the graphing method, you're going to determine 3 ordered pairs that satisfy each equation. You're going to plot the ordered pairs and sketch the graphs of both lines on the same plane. And the coordinates of the points where the lines intersect each other is going to be considered the solution. When you're graphing your 3 equations, there's 3 outcomes you can get. The first is the 2 lines can intersect each other at one point. If they intersect at one point, that means you have one solution. And when you have one solution, that's called a consistent system. So when you look at the graph, the 2 lines will cross each other. The location where they cross is going to be the solution to the system. Sometimes when you graph the 2 lines, they're parallel, which means they never cross each other. Parallel lines will have no solutions, and when something has no solution, it is called inconsistent. When you look at the graph of the 2 lines, they're going to run side by side and never intersect each other. You can also have the situation where you have a system of equations that they've given you the same line more than once, which means when you go to graph it, the graphs will be on top of each other, which means you're going to have an infinite number of solutions because every single point that's on that line is considered a solution. When that happens, this is called a dependent system. When you go to graph the equations, it will look like you only have one line on your graph because the equations will have been graphed perfectly on top of one another. So let's try to graph a system of equations and solve it. The first equation they've given us is x plus y equals 4. Now, I personally like to solve for y when I graph my equations because I like to use slope-intercept form. So I'm going to take x plus y equals 4 and I'm going to isolate my y by subtracting the x to both sides. So my first equation is y equals negative x plus 4. And remember, even if they don't list a number in front of the x, there's a little 1 that's hanging out there. So your slope is negative 1 and your y-intercept is 4. So if you were going to graph that equation, your first dot would go on your y-axis and it would be located at 4. And then you would use your slope, which is negative 1 over 1, and you'd go down 1, right 1. Put a dot. Down 1, right 1. Dot. Down 1, right 1. Dot. And I would continue this pattern until you have filled the whole grid up because you never really know where they're going to cross each other. That's your first equation. The second equation you were given was 2x minus y equals negative 1. Same thing, you want to get your y isolated. I'm going to start by subtracting 2x from both sides. And then I'm going to get rid of the negative that's on the y by dividing everything by a negative 1. So my second equation is y equals 2x plus 1. So the first dot goes on the y-axis at positive 1, and then I will use my slope to get more dots, and my slope will be up to right 1. Up to right 1. Once you find your point of intersection, you can stop. The point of intersection is the solution to the system, and you need to state the solution as an ordered pair. This is intersecting at 1, 3. So your solution to the system is 1, 3. If you want to check your answer, all you have to do is substitute 1 and 3 in for the x and the y and see if it does make a true statement. It should work for both equations. If it doesn't, then something's wrong. I can also show you how to do this on your calculator. In order to do it on your calculator, you are going to first have to solve it for y. So you have two equations, y equals negative 1x plus 4 and y equals 2x plus 1. Let's do this on the next page. So our two equations were y equals negative 1x plus 1 and y equals, it was plus 4, and y equals 2x plus 1. And we're looking to see where they're going to cross each other. So let me show you what this looks like on your calculator. I'm going to do a little video for you of the calculator. Okay, first thing you want to do is make sure your calculator is on. I have a bunch of stuff typed in there, so I'm going to hit the clear button to get it out. Now I'm going to graph my two equations. So up by the screen you have a button that says y equals. So I'm going to select my y equals. And I'm going to type my two equations in. My two equations, let's see if I can move this over, were negative x plus 4. So when you hit your negative button, make sure you're using the one down here for your negative. And then your x key is going to be this button that looks like x comma t comma theta comma n. So that'll give me my negative x plus 4. If I hit enter, I can get down to my next line. And my second equation is 2x plus 1. Then I'm going to hit the little button on the side that says graph. Oh. Okay. Okay, so I now have, sorry, I took that last screen off. I now have 2 lines graphed, and if you notice, the location of the 2 lines looks like what I graphed on the previous screen. Sometimes it's hard to tell exactly where they're crossing, and so you can use the calculate menu, which is going to be the same thing as the trace key. So you'll have to hit second and then the trace key. And you're wanting to do option number 5, which is to calculate their intersection. So I'm going to select number 5. And it's going to ask you, are you on the first curve, which I'm on the blue line flashing, so I'll hit enter. Are you on the second curve? I'm on the red line flashing, so I'll hit enter. And then it's going to say yes. So I'm going to use my right arrow key to scroll over to where I think they touch, and I'll hit enter again. And then if you notice at the very bottom of the screen, it gives you your solution. X is 1, Y is 3. Sometimes graphing is not the best method because if the lines cross at a spot that's hard to see, you will not get an exact answer. So in that situation, I would consider using the substitution method. The substitution method has multiple steps. First thing you want to do is you want to solve one of the equations for one of the variables. It does not matter which equation you do, but I always try to look for one that has a coefficient of 1, and I try to get that letter by itself. Next, once you have that letter by itself, you substitute that expression into that you found in step 1 into the other equation. What will happen is you'll be down to a single variable instead of 2 variables. Next, you're going to solve that equation for the variable. You'll substitute that answer back into the equation you worked with in step 1, and then make sure you write your solution as an ordered pair with x first and so let's look at an example. Solve the following system of equations by substitution. X plus y equals 4 and 2x minus y equals negative 1. So these take a lot of room typically, and I like to write them next to each other. So my first equation is x plus y equals 4. My second equation is 2x minus y equals negative 1. Now remember, your goal is to get one of the letters alone on one of the equations. And I always tell people to pick the equation that looks easier. To me, I think the first equation looks easier because it has less numbers involved. You have to get one of those letters isolated. It doesn't matter if it's the x or the y. I'm going to opt to subtract the y, and that's going to get my x alone. And I'll have negative y plus 4. And then what you're going to do with that is you're going to take the negative y plus 4 and put it into the other equation because it's supposed to be the same thing as x. So in the second equation, you can take the x out and call it negative y plus 4. And then you solve like normal. So you'll distribute. You'll then need to combine your like terms. You'll have to undo any addition. And you'll have to undo any multiplication. And so I ran out of room, but you'll get your y value of 3. So remember, your solution has to be written as an ordered pair, and the y always comes second in the ordered pair. Now you have to find your x, and so you're going to have to take the value that you just found and substitute it into the first equation that you were working with. Now remember, your first equation says you have negative y plus 4. So where the y is located, you can substitute your 3 in there, and a negative 3 plus 4 will equal 1. And you've solved with the substitution method. I want to do another example because every once in a while you'll hit a special case, and this is one of those problems. So again, let's choose to get one of our letters alone. This time I'm going to pick to get my y alone. And remember, it does not matter which letter. I just like to pick the equation that looks simpler. Once you have your letter alone, you are then going to take that and substitute it into the other equation for the letter that's isolated. So we'll have 2x plus 2 times negative x plus 3 equals negative 4. I will distribute the 2 and have a negative 2x plus 6. And then notice what happens here when you go to combine your like terms. They cancel. And you're left with 6 equals negative 4. Well, that's not true. 6 can't equal a negative 4. That's a false statement. If you ever get that situation, that means this problem has no solution. And if you were to look at the graph would be two parallel lines. Let's look at one more case. Y equals negative 2x plus 3, and 2y equals 6 minus 4x. Now notice in this problem, you already have a y isolated, so don't create yourself more work. You can already go ahead and start substituting in on this problem. So we can have 2 times the quantity, negative 2x plus 3, equals 6 minus 4x. We will need to distribute. Negative 4x plus 6 equals 6 minus 4x. Some people can tell right here that the left and the right hand side are exactly the same. Some people keep going until they try to get their x's collected together. And once you do that, you notice again all the letters cancel. But this time you have 6 equals 6, which is a true statement. So that means this problem is going to have infinite solutions. So if you were to look at the graph, you would have been given the same line 2 times and they would be graphed on top of each other. Whenever that happens, that's called a dependent system. It does have solutions and it has infinite solutions. Every single dot that is on the line, y equals negative 2x plus 3, is considered a solution. There's one method left, and this method's called the addition method, although many people call it the elimination method. And sometimes this can be the easier way to go if you don't have a coefficient of 1 in front of one of your letters. So to use this method, what you need to do is rewrite the equations so that the terms contained in the variables are on one side of the equal sign and that the constant appears on the other side. Then, if you need to, you will multiply one or both equations by a constant so that when you add the equations together, one of the variables will eliminate, which is why they call it the elimination method. Once you have a variable to eliminate, you can add the two equations together, which is going to leave you an equation with one variable. You will solve for that variable, and then you can substitute it into any of the equations from the beginning. And remember, you always write your answer as a point because that's what it represents. So let's look at the example. Solve the following systems of equations by the addition method. Your first equation is 4x plus y equals 13. Your second equation is 2x minus y equals 5. Now, this particular example, you do not have to do any multiplication or rearranging of equations. Notice that both the x's and both the y's are on the left-hand side and that both the constants are on the right-hand side. That's what you're looking for step 1. If it doesn't look like that, rearrange it so that it does. Step 2, what you're looking for is you're trying to get two terms to be exact opposites. So notice we have a positive y and a negative y. That's beneficial because when we go to step 3 and we add the two equations together, the positive y and the negative y cancel each other. When we add the 4x and the 2x together, we get a 6x. And when we add the 13 and the 5 together, we get an 18. Now we have this little equation that we're able to solve for x by dividing each side by 6, and you can see that x is 3. So you already have half your solution. Now you have to find the other half of your solution. You have to find the other half of your solution by substituting the 3 into one of the equations that you started with. It does not matter which equation you use, so you can pick either the top or the bottom. I'm going to choose the top, and I'm just picking that one because there's no negatives, so in my opinion, I think it's easier to work with. So I'm going to take the 3 and substitute it in for the x. So I'll have 4 times 3 plus y equals 13. Multiply your 4 and your 3 to get a 12. And then isolate the y by subtracting the 12 from both sides, and you'll get a y value of 1. Let's look at one more. This last one's going to require multiplication. If you look at your terms, notice the 4 and the 3 are not opposites of each other. Notice the negative y and the 2y have opposite signs, but not opposite numbers. So you need to fix that. So what we could do is we could use some multiplication, and we could take the top equation and double it. And when we do that, we have to multiply the 4 and the negative y and the positive 2. And then you don't need to do anything to the bottom equation on this one. And now when you look at it, you should notice that you've created two opposite terms, a positive 2y and a negative 2y. And that's good because when you add the two equations together, those y's will cancel. And you'll be left with 11x equals 11. And you can divide each side by 11, so you know your x will be 1. And then pick one of the equations. I'm just going to pick the one on the bottom. Substitute the 1 in for the x, and you will be able to solve for your y. So in this problem, my y is 2. And then again, remember, if at any time I want to check my answers, I can solve each equation for y, graph it in my calculator, and verify that they really do cross at the point 1, 2.